Whenever you walk through a busy downtown city and look up at a modern high-rise construction site, there is almost always a towering, spindly steel crane hanging 500 feet in the air, effortlessly swinging tens of thousands of pounds of solid concrete and steel beams across the sky. And looking up at that massive machine from the sidewalk, it looks like a complete physical impossibility, because there are no giant support cables holding it to the ground, no massive scaffolding surrounding the tower, and definitely no larger crane sitting next to it. In fact, if you watched a skyscraper being built from the ground up, you probably noticed that as the building got taller, the crane magically grew along with it, staying high above the top floor at every stage of the build. What most people don't realize is that these multi-ton steel giants are not assembled by giant helicopters, and they aren't lifted onto the roof by magic. A tower crane literally builds itself, jacking its own multi-ton body into the sky on hydraulic pistons, opening a gap in its own spine, and pulling new steel skeleton sections into its body in midair. To understand how a machine that weighs hundreds of thousands of pounds can lift massive loads hundreds of feet in the air without toppling over into a city street, you have to start at the ground level, because the entire survival of a tower crane comes down to a massive block of concrete buried beneath the dirt. Before a single steel beam arrives on the job site, engineers excavate a massive pit and pour a reinforced concrete foundation pad that weighs anywhere from 300 to 400 tons. Embedded directly into that sea of liquid concrete and dense steel rebar is a heavy steel anchor stool with high tensile connection legs. This concrete pad is essentially a massive counter-anchor designed to counteract hundreds of thousands of foot-pounds of overturning moment, meaning when the crane swings a heavy load out at the tip of its boom, the entire earth beneath the concrete pad is fighting that pulling force. Once the foundation concrete cures to full structural strength, the first phase of assembly actually does use a standard mobile all-terrain crane. A massive hydraulic truck crane drives onto the site and bolts the first 4 or 5 basic mast sections onto the anchor foundation, bringing the height up to around 80 or 100 feet. Next comes the slewing assembly, which is the heart and turning axis of the entire machine. The slewing unit consists of a massive circular gear turntable called a slewing ring, lined with hundreds of hardened steel ball bearings and driven by heavy electric pinion motors that allow the entire top deck of the crane to rotate a full 360 degrees smoothly. Sitting directly on top of the slewing ring is the operator cabin, the central electrical control banks, and a triangular steel framework called the apex, or tower head. Extending horizontally backward from the apex is the Counter-Jib, which holds the primary electric hoist winches and massive slabs of precast concrete ballast blocks that weigh tens of thousands of pounds. Extending forward from the apex is the working jib, which is the long horizontal steel lattice boom that carries the load trolley and hoisting hookout over the construction site. At this stage, with the mobile crane having assembled the basic working unit, the tower crane is fully functional, but it is only 80 feet tall. Now, with the building about to climb dozens of stories into the clouds, the self-climbing miracle begins. Wrapped around the outside of the vertical mast, directly beneath the rotating slewing ring, is a specialized steel collar known as the climbing cage, or climbing top. This climbing cage is essentially an oversized steel sleeve that is open on one side like a 3-sided box, fitted with heavy guide rollers that grip the 4 main vertical legs of the crane mast. Tucked securely inside the back of this cage is a massive hydraulic cylinder ram powered by an independent high-pressure hydraulic power unit, capable of generating over 150 tons of lifting force. Before the jacking process can begin, the crane operator and ground rigging crew must perform a delicate balancing act known as balancing the moment. Because the rear counter-jib is loaded down with massive concrete ballast blocks, the crane is naturally back-heavy when sitting unloaded. If the hydraulic piston tried to push the upper assembly upward while it was tilted backward, the climbing cage rollers would bind against the mast legs with immense friction, jamming the entire mechanism. To solve this, the operator hooks onto a specific balance weight, or picks up the very mast section it is about to install, and trolleys it out to an exact predetermined distance along the front jib. When the crane reaches perfect equilibrium, the center of gravity aligns straight down through the center of the vertical hydraulic piston. With the crane perfectly balanced, the crew unbolts the high tensile structural connection pins connecting the slewing ring to the top of the mast. The hydraulic pump engages, and the heavy ram extends downward, pushing its steel shoe against hardened climbing lugs welded directly into the mast lattice. Slowly and smoothly, the hydraulic piston pushes the entire 200,000-pound upper deck of the crane, including the cab, the counter-jib, the long working boom, and the climbing cage itself, 20 feet straight up into the air. Once the piston reaches full stroke, a heavy mechanical safety dog or support pawl swings into place and locks onto a mast lug, ensuring that even if a hydraulic hose blew out instantly, the entire upper crane cannot drop a single inch. Now, inside the open, three-sided climbing cage, there is a giant, empty 20-foot vertical gap where the top of the crane used to sit. While the upper crane is suspended on its mechanical locks, the crane's own hook picks up a fresh 20-foot steel mast section from a delivery truck on the street or from a staging deck. The operator trolleys the new section in toward the tower and swings it directly into the open face of the climbing cage. The new mast section is equipped with small guide wheels that lock onto monorail tracks built right into the bottom of the cage. The rigging crew pushes the new steel section smoothly along the rails into the center of the gap, aligning it directly over the existing mast below. The hydraulic piston then gently retracts, lowering the entire upper assembly down onto the new mast section. The crew inserts oversized, heat-treated high-tensile steel pins or torqued structural bolts through the corner leg joints, locking the new section permanently into the tower. The hydraulic cylinder re-anchors to the new mast lugs, and the entire self-climbing cycle can be repeated. By doing this step over and over again, a tower crane can climb 20 feet at a time, growing from a short 80-foot starter into a 500-foot skyscraper titan in just a couple of days. As the building climbs higher and the crane reaches extreme heights, basic physics dictates that a freestanding steel column can only go so high before wind oscillation and structural deflection become dangerous. To climb past 200 or 250 feet, the crane must be anchored to the building it is creating. Every 7 to 10 floors, ironworkers install massive steel collar ties or building tie-ins, bracing the four corners of the crane mast directly to the reinforced concrete floor slabs and structural core of the skyscraper. This transfers lateral wind loads and horizontal twisting forces directly into the massive building structure, allowing the crane to climb hundreds of feet higher alongside the rising tower. How the crane handles massive weight without tipping over comes down to the fundamental physics of levers and torque governed by the load moment indicator, or LMI computer system. In physics, torque is calculated as force multiplied by distance. That means a crane lifting a 30,000-pound load close to the mast at 20 feet produces 600,000 foot-pounds of bending force. But moving that same 30,000-pound load out to the 200-foot tip of the jib would create a catastrophic 6 million foot-pounds of torque, which would tear the steel lattice apart. The onboard computer constantly calculates line tension, trolley position, wind speed, and hook angle, and if an operator tries to push a load beyond the crane's certified load chart, the system automatically cuts power to the trolley and hoist motors before an overload condition can occur. When extreme weather and hurricane-force winds hit a skyscraper job site, the crane faces its most dangerous hazard, wind shear. You might think the safest thing to do during a storm is lock the crane's rotation brake solid so it doesn't move, but doing that would actually cause the entire crane to collapse. If a 200-foot horizontal steel boom is locked perpendicular to 80-mile-per-hour winds, the flat surface area acts like a giant sail, creating enormous torsional twisting forces that will shear the bolts right off the mast and snap the tower in half. Instead, when high winds approach, the crane operator puts the machine into a state called weather vaning or free slewing. The operator disengages the mechanical slew brakes completely, allowing the entire upper jib and counter jib to spin freely 360 degrees. Just like an arrow or a wind vane on a barn roof, the wind naturally pushes against the longer surface area of the front jib, rotating the crane so the sharp tip of the boom points directly into the teeth of the storm. By slicing into the wind rather than fighting it, wind resistance drops to near zero, allowing the tower to survive violent storm gusts safely. When the skyscraper is completely finished, the crane faces one final puzzle: how to get down. The dismantling process is simply the self-climbing procedure run in reverse. The hydraulic climbing cage unbolts a mast section, lowers the upper crane 20 feet, pushes the unbolted section out on the monorail, and the crane's own hook lowers the steel beam to the ground. If the building has enclosed the crane, or if ground clearance is blocked, crews install a smaller, specialized rooftop derrick crane on the roof of the skyscraper. This rooftop derrick dismantles the main tower crane piece by piece and lowers it down to street level, and then the derrick crane is disassembled into small modular pieces that are loaded directly into the building's standard freight elevator and wheeled out the front door, leaving behind a finished skyscraper with no trace of how the giant machine ever left the sky.